Alright, I got my simulation here. I'm going to go back. I'm going to set it for to allow motion. So I tell it I want motion. I want this part to be moving. And edit. I would like this to move in angular motion so that it rotates. And I'm going to tell it flow-driven motion, so the water makes it spin. It doesn't spin on its own. If I wanted it to spin on its own, then I could go and edit that motion, and it would give me this option to tell it how fast it's spinning. In this case, I want flow-driven motion, and I'll apply that. So now I have flow-driven angular motion. I come over to solve. Other things are the same. I've still got the same boundary conditions. I've got the same part, same water. I'm going to tell it to calculate from 0. I'm going to tell it to run, I don't know, 100 iterations. That won't be a ton of time, but then I'll tell it go ahead and solve. And it's going to delete all my old results, and it's going to start solving again. And here it goes, it's meshing. And now it's calculating. Now, one of the big things to do with CFD is you need to validate CFD results in the real world to make sure it's not just a pretty picture, that make sure that this actually lines up with something you're seeing. So one easy way to validate the result would be to stick it in an environment where there's 2 meters a second of water flowing over it and see if it really does rotate as fast as this predicts that it will. Or see if it starts rotating when it says, or measure the wind speed at various points and see if it really is what it says it should be. You have to go back and make sure that, again, it's more than just a pretty picture. Alright, that's how you set up a motion